So I thought of an alternative title for my talk. It's not as sort of directly snarky about humanism, but it is a kind of like, come on, let's be honest. But I think it's important for you to hear it in David's voice. So the new title for the talk is, Look. Come on. If you're going to be Humean, then be Humean. Stop trying to be something you're not. Yeah, that's the new title. And to explain that, I'll just a little brief bit of intellectual autobiography. When I first learned about debates about objective chance and the Humean approach to objective chance, that was back in probably the early 90s with David Lewis. And there's a way in which, and those of you who are familiar with Lewis's work will understand what I'm about to say very quickly, but there's a way in which Lewis was an extremely conservative philosopher, not in the political sense. So even though we all know he had a view about chance that was revisionary on its face in certain key ways, right? So for example, according to Lewis, you could not say that two worlds could agree exactly on what happens in them but disagree on their chances. And that's obviously revisionary. You think to yourself, what are you talking about? I could have two coins with different biases, and when they're flipped, nevertheless, they land in exactly the same sequence of heads and tails. And then, of course, there's the stuff about undermining futures that we'll come back to. So Lewis was fully aware that there were these revisionary consequences, but he really was clear that he wanted to limit them. And I think that came over the years to seem to me a very strange attitude. In fact, I think if you think seriously about the background metaphysics that a Humean endorses, you should expect their views about the physical modalities generally to be revisionary. And I think it's interesting to see how revisionary they look in the case of chance. That's what I'm going to try to explain today. Now, I might be wrong about that. When I think about the right way to lay, what seems to me to be the right way to lay out Humeanism, I do not think that the thing to do is what Lewis did, which is to collect together various claims about chance that we treat as platitudinous, and do your best job to analyze chance in a way that secures you the right to continue to say them. That was a kind of standard Lewis methodology. The reason I think that's a bad methodology, well, there are a lot of reasons, but for present purposes, one reason to foreground is that if you do that, if you think the name of the game is this kind of old-fashioned conceptual analysis where you will have succeeded to the extent that you've got an overall system that's nice and coherent, that's a constraint, but within that, you get to preserve as many quote-unquote platitudes as you can about the concepts you're analyzing. If you do that, and like Lewis, you have a background motivation that's very Humean in its metaphysics, you face what seems like an obvious question once you state it, like, why bother? Like, you know, if this is your account of chance, like, given your background metaphysics, why would you want a concept that worked that way? Like, and another way of putting it is, what's so great about preserving the platitudes, given your background metaphysics? And I think that's, so the point of the altered title is like, try to nudge Humeans in the direction of like, no, lean into your revisionism. But I think it's important to see how extensive it can be if you adopt this attitude. So that's what I'm going to try to sort of walk through and explain today. I should say Hume, at least, was very upfront about this. We've just been, in our first year colloquium, our graduate seminar for first year graduate students, we've been working through book 1 of the treatise. And you know, he's very in your face with his revisionism. Now, it's kind of refreshing, even if it's bonkers. So a couple things I wanted to emphasize at the outset. If you look at section 1, I won't read through it, but there's a kind of standard presentation of the divide between Humean and anti-Humean approaches to physical modalities, by which I mean things like laws, causation, powers and capacities, chance being our focus today. The usual, like the traditional way of trying to capture the core of that divide was by some thesis like HS there, some supervenience thesis. And I think that thesis is important, but I think it misses a certain way of approaching Humeanism that I find sort of more clarifying. And there are actually a couple components to this. So first, I'm assuming that in this room we're fairly familiar with the background Humean metaphysics. That the cosmos as a whole is just one damn thing after another, at some suitably fundamental level. There are nothing like any necessary connections between things. There are no necessities of any sort in nature itself. And we could make that claim a lot more precise if we wanted to. So two things I think are worth noticing about that. One is, if that's your view of the cosmos as a whole, or of reality as a whole, then it's probably going to need to go along with a certain view that's already revisionary about what the project of explaining the world to ourselves is. No. So what's the contrast I have in mind? I don't want to try to get into this in too much detail, but I'll try to make it sort of evocative. Sometimes we think we can explain features in the world by directly appealing to other features in the world that constrain them to be the way they are. No. At least this is a natural way to think. It's not a way Humean will think. But I think it's the way Tim thinks, for example. If there are regularities in phenomena, in some cases, if those regularities are basic or fundamental enough, the right thing to say about why they obtain is they have to obtain. The laws guarantee that they will obtain. There can be a statistical analog to this. If there's statistical regularities throughout all of space and time, and they connect directly enough to the fundamental stochastic laws, then you might say, the statistical regularities obtained, well, the best explanation we can give of that adverts to the constraint imposed on reality by the fundamental stochastic laws. Causal explanations are more complicated because they mix stuff about constraints on phenomena with other stuff, just de facto information about the phenomena. But in the background of most explanations we give of worldly phenomena, at least on one way of thinking about explanation, those explanations count as such or earn their keep as things that give us understanding because of the way they highlight information about constraints on that which is to be explained. No. And I think you should sort of be upfront about this, objective metaphysical constraints on what's to be explained. That's one kind of big picture view about how explanation works. Explanation, at least in the natural sciences, mathematics is another matter, but explanation in the natural sciences has as one key aim the provision of information about objective constraints on that which is to be explained. And I think a Humean just needs to just abandon that right up front, right? And Lewis did not, no, at least not clearly. But I think you should. I think, look, you've already told us that the world doesn't have any such stuff in it to point to. There are no explanatory constraints in the world. You can talk as though there are, but I think an honest Humean should view that talk as being serviceable for some other reason, not because it's a way of conveying information about genuine objective constraints on the phenomena to be explained. Okay, so if that's right, then a question that we can ask about any view of the physical modalities, or just any view about any philosophically interesting concept, takes on a particular urgency for a Humean. So here's the question I have in mind. When you're giving an account of some philosophically interesting concept, you can step back and you can say, well, having gotten the account on the table, what rationale could we give for even having a concept of this sort? What's the value to us of having a concept that works the way this concept does? And sometimes I think that question has a very easy answer. So Tim, for example, so this is section 2 on the handout, gives, not an account in the sense of a reductive account, but a kind of philosophical story about what laws of nature are. And one of the key passages is the first one there. He says, my own proposal is simple. Laws of nature ought to be accepted as ontologically primitive. We may use metaphors to fire the imagination. Among the regularities of temporal evolution, some, such as perhaps that described by Schrödinger's equation, govern or determine or generate the evolution. But these metaphors are not offered as analyses. In fact, it is relatively clear what is asserted when a functional relation is said to be a law. Laws are the patterns that nature respects. To say what is physically possible is to say what the constraint of those patterns allows, right? And Tim is very clear this is not meant as he's not in the business of trying to reduce claims about laws to others. But one can say something partly there and partly by connecting the concept of law to other concepts about what sort of structure in the world you are talking about when you talk about laws and why it's important to talk about that structure. So if you asked, well, we could ask Tim, on your view, what's the rationale for us to even have a concept of law? I'm going to answer for you, but you can sort of correct me. Look, how else are you going to talk about this stuff, right? There's this feature of reality that's really important. Knowing about it is crucial to understanding the world. If you don't have a concept for it, you can't think about it, you can't communicate about it, right? It's a very simple answer to the rationale question. The answer for the Humean is not going to be so simple. I don't mean to say that there isn't an answer, but it's going to require a lot more thought to think about what the answer could be. And without going into too much detail, I'll just sort of give you maybe one model. It's not a perfect model, but it'll sort of steer you, I think, in the right direction for how a Humean might approach this question of rationale. What's the point or rationale of even having concepts of like law, causation, chance, and so on? So forget about the physical modalities for a moment, and imagine, so it's going to be a little bit out of left field, but imagine that we're all like deeply interested in number theory. We love investigating arithmetic, and we want to do this collectively, and we want to do it rigorously. And we find that certain claims about the numbers strike us as really obviously true. Certain simple enough claims about the numbers strike us as very obviously true, perhaps so obviously true that we would not find them more obvious by virtue of proving them from other claims, right? And maybe we think like, look, given our interest in investigating the numbers, we want to kind of foreground obvious truths and use them as starting points for deduction, because as long as we've got a system of deduction that we're confident in, then we can transfer, by means of deductions that use that system, we can transfer the obvious truthness of our starting points to other claims. And we might want, to coordinate on this. It might be that if I say, David, I've got this great proof of Fermat's theorem, it fits into a margin, David will say, great, like show me, but can you start from this starting point that we've both agreed upon? And we might also want the starting points to be sort of minimalist. It might be illuminating to us to see how much we can get from a relatively small number of starting points, and hopefully you can see where this is going. Right? Ultimately, we're going to end up on a list of arithmetical truths that we're going to sort of dub. We're going to give a name to. We're going to call them axioms. Right? And this is an origin story for the concept of axiomhood that is not metaphysical. It's not that we hit on, certain, we decide to nominate certain arithmetical truths as axioms because we think that somehow in Plato's heaven they shine more brightly, or they more accurately sort of capture the essence of number. You could have a view like that. I don't mean to, okay, I was kind of making fun of it, but I didn't really mean to make fun of it, right? Like maybe that's a reasonable view. I just wanted to like put on the table an alternative way of thinking where, no, as far as the metaphysical facts are concerned, like in Plato's heaven, it's perfectly egalitarian. An arithmetical truth is an arithmetical truth. But some of them relate to us and our cognitive equipment differently than others do. And for our purposes, especially our collective purposes as sort of inquirers into the numbers, we find that there's a good rationale for picking some of them out and having a name for the ones we picked out. So you can see, I'll quote Lewis here, sort of dimly, but maybe well enough, how an approach like that might give you a story about the rationale for having a concept of law. But it's a rationale that's only going to make sense if you've already come equipped with a different way of thinking about explanation, a very, very different way of thinking about explanation from the constraint focus. And it might, we don't actually have such a theory of explanation. And if some of you made the mistake of looking at my attempt to point to it in the paper, just ignore that, because that was a botched attempt for reasons that Tim pointed out. At some point, Tim's going to stop coming up in this talk, but not yet, right? But I think there is, if you wanted to sort of find precedent for a different way of thinking about what it is to explain some phenomenon, it might be that you'd want to look at mathematics, right? And you'd want to look at mathematics in particular because there you might be able to find illuminating examples of explaining some mathematical truth by showing how it fits into some overall organizing scheme. At any rate, that's my working hypothesis about the background view of explanation that an honest, Humean really needs to be working with. Yes, in inquiring about the world, we do not merely aim to extrapolate out from the limited set of data we have about the world to a sort of broader view of the world. We're not merely trying to extend our knowledge of what the world is like. We're trying to understand it, but we're not trying to understand it by finding information about constraints. We're trying to understand it by finding a kind of organizing scheme that's sufficiently comprehensive that we can sort of illuminatingly fit any particular phenomena that we're curious about into it. That's the kind of guiding picture. Okay. And again, I think that guiding picture is going to lead you in very revisionary directions when it comes to chance in particular. So, well, I say revisionary with respect to what, right? What's the quote unquote normal view of chance that a Humean approach is going to diverge from? I kind of like the view that, here you are again, Tim lays out in What Could Be Objective About Probabilities as a kind of clean statement of this. That objective probabilities are, in the first instance, connected to fundamental stochastic laws, laws of temporal evolution, but stochastic laws of temporal evolution. So here's an evocative quote. And again, you know going in, you're not going to be reducing the notion of chance to anything else, right? You're connecting it, of course, maybe even analytically, to fundamental dynamical laws. But that's not, that's not functioning as a kind of analysis. So Tim says, the most straightforward account of probability appeals to fundamentally stochastic dynamical laws. Doubtless the behavior of tritium is a consequence of the laws governing its subatomic constituents, but that complication need not detain us. If the fundamental laws are irreducibly stochastic, then they can either directly assign or indirectly entail. Note that indirectly entail, we're going to come back to that. A probability density for decay, and hence allow one to calculate the likelihood of decay for any tritium atom over a specified period of time. The laws would allow initially identical tritium atoms to decay at different times, assigning a probability to decay within any specified period. The probabilities involved specify how likely it is that a system will evolve in a certain way, given that it started in a particular physical state. So this may be tendentious, but I'm going to treat this account as capturing the normal view of laws and chance. And it has certain features that are maybe, I'll try to quickly run through some of them. So of course, it's going to turn out that laws and observed frequencies can diverge, right? We could get unlucky. In fact, you can calculate the probability that we'll get unlucky. That's just given going in. Chances, at least down at the level of fundamental physics, are also going to be perfectly precise. I don't think that's non-negotiable on this view. I suppose if you wanted to, you could take a Tim-like view towards objective chances and stochastic probabilistic laws and say, well, there's some sort of objective vagueness in what the half-life of tritium is. No. But that's not the natural way to go. And I think that connects to a general feeling that when you're talking about fundamental aspects of the world structure, vagueness and indeterminacy just have no place there at all. Right. So whatever, maybe tritium is a bad example because it's a complicated enough thing that there's some vagueness in the way we pick out the object. But if you're talking about, say, the GRW theory, they'll have a proposal about what the average time to collapse is. They may be wrong about that. But it's a presumption of the theory that if it's correct, there is some absolutely precise value of that constant. The same way you'd say, look, in Newtonian gravitational theory, there's some absolutely precise value of the gravitational constant. Because it reflects some fundamental feature of what the world is like. There's a sense, and Tim alludes to it here when he uses that word indirectly, there's an important sense in which the objective chances here are imperialistic. And this also comes up in some of David's stuff on statistical mechanical chances too. If you think about the probability that's laid down by the fundamental stochastic laws of evolution, and you ask well, sure, those are chances that govern tritium atom decay and stuff like that. But what about, the chance that I'll crack another joke in this talk at David's expense? Do they say something about that? The answer would be yes, they do, right? We may not be in a position to calculate that, but anything that has an objective chance has it in virtue of those laws, right? They're imperialistic in that sense. It's not like there are chances for tritium atoms and then there are chances for sort of bad jokes made at David's expense, right? And this is what I was thinking about in your work, David, is when you say, look, there's going to be a chance that, your cabinet drawer has a ladle in it or whatever. And one last thing, I don't think this exhausts things, but it's also indicated in what Tim says, chances are transition chances. What chances attached to is that, claims the evolution from this point forward will be this way. So on this view, if there's an initial state of the universe, there's no such thing as the objective chance of that initial state. Okay. All right, so that's what I'm operating with as the foil, the sort of normal view with respect to which a Humean account is going to look revisionary. So how do we get at a Humean account? So we're rapidly making progress here. We're on section 3. I'm assuming that most people in this room know how, like in outline, how a best system approach to laws works. I'll just make some quick comments about my preferred way of thinking of the architecture of such a view. I think a candidate system is in the first instance going to make some claims about what the world is like. And the best such system is going to thereby delimit what worlds count as quote unquote nomologically possible. The scare quotes are there because, of course, nomological possibility and necessity are not meant to pick out some kind of structure out in the world. Right? This is like a conceptual grid we're imposing on the way we think about the world. And then what a probabilistic candidate system will do is then once those space of nomological possibilities is carved out, it will propose a kind of Ur probability distribution over them. Like, I think this is a kind of clean way for a Humean to think about this. Partly because I sort of have in the back of my mind that there's going to be some story about what counts as best, and an attractive version of that story is going to make this the kind of right architecture with which to set up the view. So the story I have in mind is something like, well, let's zero in on that probability distribution in particular. What makes it count as best? Well, Lewis thought very much in terms of simplicity and informativeness of the overall system, and thought when we add probabilities, we have to add something like statistical fit. But what you see in more recent Humean work is a kind of more pragmatic turn. The probabilities posited by the best system should be the sort of probabilities that would serve us as good guides. And you see this like really vividly in this quote from David in Physics and Chance. David actually leaves out part of the story. Here's the idea: you get to have an audience with God, and the part you left out is when God says, "Oi, David, you again. What is it this time?" And David says, "Can you tell me some information about the world?" And then God promises to tell David whatever he'd like to know, and he asks him to tell him about the world, and he begins to recite the facts: such and such property, the presence of a particle, say, or some particular value of some particular field is instantiated at such and such a spatial location, etc. And you explain to God that you're actually a bit pressed for time, that this is not all you have to do today, that you're not going to be in a position to hear out the whole story. And you ask if maybe there's something meaty and pithy and helpful and informative and short that he might be able to tell you about the world, which you understand would not amount to everything or nearly everything. Pause right there. So far, you've got a kind of motivation story for Lewis's way of thinking what a best system should do. It should give you a lot of information about what reality is like in a compact form, sort of easy to grasp form. That's a sort of story about bestness that I think runs straight into trouble. I'll just leave that off stage. But then there's a pivot here in what David says. And once you see the pivot, you can see a very different way of thinking about bestness, particularly when it comes to probability distribution. OK. Where was I? You ask if, right, about the world, which you understand would not amount to everything or nearly everything, but would nonetheless still somehow amount to a lot. And here's the key: something that will serve you well or reasonably well or as well as possible in making your way about in the world. Right. And that's the pragmatic turn. Was that intentional, that it be pragmatic in that way?
It's a long story.
All right. All right. All right. So there's plenty of room for debate within a Humean camp here, right? Like you could, when I said it's a hard question that Humeans really need to think through carefully, what's the rationale for concepts like law and chance in particular? When it comes to chance, there are very different ways to go. You could have a kind of purely intellectual rationale that's continuous with the Lewis-style rationale for having laws. You think like, well, look, reality might be such that there's no compact informative system that has a deterministic structure, right? It might be that, there are sort of like interactions in the world that are repeated over and over again. We're going to see a toy example in a second, where sometimes they go one way and sometimes they go another way. And thanks to that, there's no sort of compact way to describe the world using sort of deterministic dynamical principles. But you could impose probabilities as a kind of way to compactly convey quite a lot of information about this statistical structure. And that's a way to go. That's the kind of rationale that foregrounds our kind of purely intellectual curiosity about the world. Like we want, a compact amount of information, well, in a deterministic form if we can get it, but about the statistical character, global statistical character of the world if we can't. But there is another way of going, which you see, whether or not David intended it, you see here, which is, well, when it comes to the probabilities, one measure of their bestness is like, are they the sorts of things that would guide an idealized version of us well, would serve us well as credences, say, right? And you might want that because like you might be looking ahead and thinking like, well, I'd like these probabilities to fit into a credence chance principle in a natural way. Right? Okay, so we can leave it up in the air exactly where a Humean ought to go on that rationale score. But either way, it makes sense to set things up by saying there's a kind of chance function. Because, and this is one of the kind of main selling points that people like Barry and David will tout for their approach to probability, look, you can convey quite a lot of useful information if you include in your probability distribution a probability distribution over initial conditions. Quite a lot of information. In fact, part of what made me think that you did have a very pragmatic notion in mind is your own sort of observations about how for creatures like us, at the scales at which we operate, a deterministic theory like Newtonian mechanics is pretty much predictably useless on its own. Right? Okay. All right, so there's sort of quick overview of what a best system account might look like. Just going to keep an eye on the clock. I'm going to sort of zip through some ways in which this is revisionary that are going to be familiar. And a lot of this is not new. What I was attempting to do here is just collect together a bunch of observations about the revisionary character of Humean approaches to chance, because I think it's good to see them all displayed at once. But to do this, it'll help to have a nice simple toy example. So that's section 4. So imagine that the world we live in has a sort of conceptually easy fundamental ontology. There are particles that move around. And particles sometimes enter these things that I'm going to call T-junctions. This is picturesque, obviously. You see what the point is. We want some kind of interaction for the particles to undergo that can have one of two possible outcomes. And when they enter T-junctions, sometimes they go left, and sometimes they go right. If we're thinking about this in the sort of normal way that Tim highlighted, the natural thought would be, okay, so there are going to be other dynamical laws. They're sort of off stage, but there's going to be some fundamental stochastic law, some fundamental dynamical stochastic law that just specifies the probability that a particle entering a T-junction goes left or right. Right? That's going to be some fundamental constant that characterizes this world. All right. So that's the kind of world I want you to imagine, though. Of course, a Humean will say, look, all we've actually got at the fundamental level are the facts about which ones go left and which ones go right. So you can quickly see how a view like a world like this can lead to the possibility of undermining. If we think of chances at a time, okay, so let me back up a little bit. I said my preferred way of kind of thinking of the architecture of a Humean view about chances, you've got a story about what the nomological possibilities are. The best system gives you that. And then you've got a sort of chance function over those nomological possibilities. How do you get chances at times? The obvious thing would be to conditionalize the chance function on some appropriate proposition. For example, a proposition completely detailing the state of the world at the given time. Right? So let's go with that. Right? If we think of chances at times as deriving from an chance function is this way, conditionalized, I chose the first option on the complete physical state of the world at that time. On the normal view, a possible world that has some chance of obtaining is going to be a world with those chances. Right? This is not something I highlighted when I was laying out Tim's view. But on a normal view, when we think about what's nomologically possible, that's going to be given by whatever the fundamental laws of temporal evolution are, maybe plus some laws like restricting the space of possible initial conditions. Okay. That will sort of generate a model that will tell you, like, here are the nomologically possible ways the world could go. On the normal view, it is kind of baked in. I suppose you don't have to. It's not logically forced on you to bake this in, but I think it typically is baked in, that those nomologically possible worlds are worlds with exactly the same fundamental laws, right? So those worlds with the same fundamental laws would, a fortiori, be worlds with the same fundamental stochastic laws, right? And that's a feature that's just pretty clearly going to need to go missing on a Humean view. You can squish it in if you want to. This is something Frank Arntzenius noticed like about 15 years ago or so. But you get a really ungainly approach to probabilities if you do. So on a Humean view, if you thought about how a best system account of this world might go, well, there's going to be the part of the best system that issues in the sort of dynamics that's off stage, that tells you what the basic inventory of fundamental stuff is, tells you how it behaves outside of these T-junctions, and then there'll be so far that part of the best system. If we remember, we're sort of separating the task of constructing a best system into the task of specifying the nomological possibilities, then imposing a probability distribution over them. So we complete the first part of the task if we just add the sentence, whenever a particle enters a T-junction, it goes either to the left or to the right. And that's all we add. So that gives us a kind of qualitative dynamics. Qualitative in the sense that there's nothing has been said about probabilities for the world to evolve one way or the other. But what we will augment that with is like some probability distribution over those nomological possibilities. And depending on what the statistics are like in this world, it might be that we'll agree that the simplest, cleanest way to do that is to have probabilistic laws of evolution that just specify a probability for going left or right that's equal to the global frequency with which particles go left or right, and then is filled out into a complete probability distribution by treating all these events as probabilistically independent. All right? Right. So if that's the recipe, then of course that probability distribution is going to allow as possible or that sort of overall set of laws is going to allow as possible worlds in which the frequency is different. In which case, in those worlds, the chances, the fundamental chances, or the things we call fundamental chances as Humeans, those are going to be different. And that's the sort of undermining. That's at the bottom of Lewis's worry about undermining futures. It really doesn't have anything to do with futures. The core observation is that on a Humean view, it's going to be more or less inevitable that the view will count as nomologically possible worlds with different probabilistic laws. And in fact, there's an analog in the deterministic case too. Even in deterministic best systems, typical ones will count as nomologically possible worlds with different deterministic laws. Okay. So that's familiar. Let me go through 6 and 7 relatively quickly. 6, I'll be really quick. One sentence. There's no particular reason on Humean view of chance to expect chances to be precise. There, done. OK. 7, when it comes to explanation, I want to highlight one kind of example in particular. On the normal view of chance, there's going to be all the difference in the world between phenomena that are governed by a probabilistic law and phenomena that are governed by merely non-deterministic dynamics. Or in the example I'm thinking of, it's actually not the dynamics that issue in the non-determinism. But you'll see when I lay out the example. So here's an example. This may be familiar to many of you. Imagine a kind of world of billiard balls floating in space that occasionally knock into each other. And when they do, they undergo perfectly elastic collisions. And that's it so far. Right, so the world is so far looks pretty boring. There's like space. Maybe it's like Newtonian space. It's filled with billiard balls. The only kind of interaction are these elastic collisions. No other sort of long forces between them. But there is one interesting thing in this world. Like over here in space is something we'll call an entrance portal to a time machine. Really, you could think of it as like the topology of space-time is messed up in a certain way. And over here is the exit portal, the quote-unquote exit portal. What that means is like something that enters here at one time exits here at an earlier time. All right? All right. And like, so here they are right here. All right, this is going to be hard to do with just two hands. My nose is a billiard ball. It's going up like this. And if we set things up right, you can see how this could go. Two things could happen consistent with the dynamics I've just laid out. Right? One thing is like, billiard ball just sails right in between the entrance and exit portal. Nothing interesting happens. The other thing that could happen, consistent with the dynamics I've just specified, billiard ball sails through, and at just the right time, a billiard ball, that billiard ball, in fact, sails out of this thing, the exit portal, knocks into this billiard ball. The one that exited out goes like this, and the one that got knocked into goes like this and into the entrance portal. Right? Did everybody get the example? All right, so just reflect on that example for a minute. If we ask in a particular case, suppose there is, in a particular case, there is a self-collision, and in maybe some other case there isn't. If we ask a natural explanatory question, why was there a self-collision in this case whereas there wasn't in that case? There is nothing at all to say by way of explaining that. Nothing, zero, nada, right? All you can point out is that the dynamics, together with the curious space-time structure, permits both options. And one happened in one case and the other happened in the other case. But that is just to reiterate the presupposition of the question. It's not to answer the question. You can't answer that question. There is no explanation when a billiard ball undergoes self-collision or when it doesn't, why it did rather than not. And this absence of explanatory information scales up. If we have a gazillion billiard balls sailing through this thing, and 30% of them undergo self-collision, and the 30% that undergo self-collision are nicely randomly distributed, of course, if you were watching this, you would be tempted to posit an explanation of that statistical regularity. You'd say, like, there must be some kind of probabilistic constraint working in the background. Like, that would be a very natural temptation. But it's my example. I get to stipulate what's true of it. There isn't. I told you what the dynamics was. That was the whole story. So in fact, you would be misled. There is no explanation for why there's a regular statistical frequency of 30% of self-collisions. None whatsoever. Nada. Zip. Zero. Right. A Humean cannot possibly say that. Right? For a Humean, you get enough data, you get a statistical regularity that's pervasive enough, and it puts pressure on the candidate best system to include information about it. And so willy-nilly, you're going to get in your best system a probabilistic law that says there's a 30% chance of self-collision. Now, it's a little weird, right? Well, it's weird immediately because you think, like, no, this wasn't explicable, and now you're sort of saying there's a law that applies to it. Now, bear in mind, for a Humean, the law doesn't explain it in the way it does for someone who takes the normal view. It simply merely systematizes it. But that's a way to dramatize the difference between the two approaches and sort of bring out what's revisionary here. It connects directly to, I think, to the difference in explanation. We feel, at least those of us who are attracted to the normal view feel there's all the difference in the world between this case and a case of a genuine, a statistical regularity generated by a probabilistic law with respect to explanatoriness, or whether it can be explained. A Humean can't see such a difference. There's the other thing that's a little bit odd about this is, a Humean would posit a probability distribution here, would have to, because the demands of bestness require it. But you can't pin the probabilistic behavior onto any interaction here. The interactions are not probabilistic. That's just a curiosity. I think the main thing to emphasize is we get a dramatic difference with respect to what sorts of things can be explained. Now, penultimate thing, we also, I think, and this is bound to be more controversial, I think we get a dramatic difference with respect to what importance we place on independence principles. So I'll just focus on one. So if we go back to my T-junction world, imagine we're scientists in that world, we're investigating the behavior of these T-junctions, and at first we only have like aggregate data about them, and we get, maybe our best data tells us 30% of the time they go left, 70% of the time that they go right. And then we're, with advances in technology, we're able to actually track individual particles through successive T-junctions. And we notice something absolutely remarkable, that in every, we can sort of, looking at the history of one particle moving through T-junctions, we can sort of portion out that history into sections of 100 entrances of, enterings into T-junctions. And in every such 100-length segment, we see 30 left exits and 70 right exits. Right? That would be a stunning discovery. We think, holy shit, what is going on? Right? And what we'd want to find, the first thing we would look for is something about the particle that carries a memory of what it did. Right? Some intrinsic physical parameter of the particle that's altered in some way when it goes through the T-junctions. Like, that would be the first order of business for fundamental physicists there, to find that, see if you could manipulate it, come up with a theory of it, and so on. Right? What I don't see is why, for a Humean, there should be any such pressure to do that at all. Right? Why not? Well, look, for a Humean, there's some pressure. There's a sort of modest pressure to expect that the probabilistic laws will treat each T-junction event as independent. Why is that? Well, because look, if you've got a bunch of phenomena and you're trying to systematize the statistical behavior of the phenomena, you're trying to say something compact about the statistical behavior of the phenomena, it's gonna be easier, it's gonna make your life easier if you just build in an independence assumption, because then you can compactly say what the probability distribution is, right? But look, if there really is this kind of regularity in nature, to leave it out of your best system comes at a really great cost. And it's not that much of a cost in terms of additional complexity to your best system to add it in, to say,
just repeat what the regularity was.
yeah, so each particle, over a course of 100 entrances, will, not every course because they overlap, right? But over a course of 100 entrances, will go left 30 times and right 70 times. Yeah, exactly.
This made up world.
Yeah, that's right. That's right. I'm not sure what you would think about me if I was talking about the actual world, right?
I smell a Nobel Prize.
Yeah. Right. So as a Humean, you might think, well, look, there's a presumption in favor of the probabilities that the best system issues into have this Markovian condition built into them. That presumption comes from a presumption in the favor of simpler best systems over more complex ones. Certainly you wouldn't, if you didn't have to, you wouldn't violate the Markovian condition in your specification of the best system probabilities. But in this case, it looks like, that the chances pertaining to an event given one state of the world at a time, if we take this chance function and we conditionalize it on the state of a world at a time, we thereby screen off any information about the past. Right. And maybe this wasn't clear enough, but when I said physicists would be looking for memory traces within the particle, it's so that they could preserve that claim. Is that clear enough? Okay. But for Humean, hopefully the point is clear enough. There's some pressure to preserve that Markovian condition, but it's not that great, right? So I originally thought about this in the context of Bell's inequalities. The sort of slogan for him is for Humean, the Bell's inequalities, the violation should be yeah, okay, But it's a little bit more dramatic here, I think. I'm not sure why. I will just self-report that I think the violations of Bell's inequalities are really weird. I think the violation of a Markovian condition would just be insane, right? But maybe by saying that, I'm revealing my non-Humean sympathies. Okay, so that strikes me as a very sort of a much more sort of in-your-face sense in which a Humean approach to chances is revisionary. The last thing I want to talk about is this thing I mentioned earlier about imperialism, about how on the normal view, a specification of the fundamental probabilities is thereby a specification of all objective chances. Again, there's no, here the dialectic is a little bit more complicated in ways that I'll try to sketch. But I think at the end of the day, there's no decisive reason why a Humean should expect that to be the case or should demand that it be the case. You can build it in to the way you construct a best system. You can say, look, there's one best system. It specifies this probability distribution and thereby implicitly specifies probabilities for everything else. But it's open to a Humean to be pluralistic about candidate systems. And one reason that I've left kind of off stage is it's open to a Humean to be pluralistic about the languages that you appeal to in constructing a candidate system. So I didn't go into this in detail before, but like one thing a Humean needs to tell us about is like when you're considering a range of candidate best systems, I said a best system has the form, or a candidate best system has the form of a set of true sentences about the world in some language, and then a probability distribution over the possibilities that are compatible with those sentences, the things we call nomological possibilities. All right, what's the language in which these sentences are written? And Lewis worried about that, and he had a motivation which I think is not, at the end of the day, a very good one for thinking there had to be a unique such language. And then sort of Berry has this much more sort of like postmodern view that no, there could be like a range of, yeah, that the language itself could be one of the things that's sort of a choice you make, that the goodness or badness of which gets evaluated when you consider a candidate system. But at any rate, there's room for a Humean to be pluralistic and say, well, depending on what scale we're operating at, what scale we're describing the world at, we might want to help ourselves to different languages. So to sort of bring this thought into focus, imagine a little sort of system that is, it's not completely described on the handout under 9, but one feature of it is. We'll call it a maze. And a maze has some T-junctions in it. There's more to a maze than that. That's important for reasons I'll get to in a second. But when a particle enters the bottom gray dot, it encounters the first T-junction. It goes either left or right. If it goes left and left again, it comes back to that central dot. If it goes right and right again, it comes back to that central dot. If it goes left then right, it exits at the white dot. If it goes right then left, it exits at the black dot. Okay. And so one thing to notice is that if you have the normal view and you include in your normal view this Markovian condition, it's automatic that the probability, unless the T-junction probabilities are extreme, 1 or 0. It's automatic that the probability of exiting at the white dot is equal to the probability of exiting at the black dot, right? That's sort of inescapable. But as a matter of like logic, nothing about the statistics, the bare statistics of left exits and right exits imposes a constraint on the statistics for white dot exits and black dot exits, right? If you just wanted to design a world that had, maybe it had like a gazillion mazes in it, and it had 10 to the gazillion T-junctions in it, So lots and lots of T-junction, events of particles entering T-junctions. Lots, not quite as many, but lots of events of particles entering mazes. You can mix and match the statistics over all T-junction exits with the statistics over mazes however you like. This is an exercise, but it's not that hard to see it, right? In fact, you can even do it if the only T-junctions are the ones that exist in mazes. But it's sort of easier to see it quickly if you just help yourself to lots of other ones. Well, so suppose you could have a world, a possible world, certainly Humean would have to recognize this as a possible world, where there are lots of mazes, and the percentage of exits from the white dot is 30%. And it really doesn't matter what the percentage of exits from T-junctions, left exits or right exits from T-junctions is, but suppose that's like 60% left and 40% right. So it's perfectly possible to construct a world where these two statistics, the statistics at the scale of the T-junctions and the statistics at the higher scale of mazes cohabit comfortably. And now we could ask, well, what would a best system or systems for such a world look like? And if you're a Humean of a more pluralist bent, then it's open to you to say, well, there are objective chances that pertain to T-junctions. There are the probabilistic laws that I'll write when I'm using a language that's particularly apt for describing the world at that scale. And then there are probabilities, objective probabilities for mazes. And they come out of a best system written in a language particularly apt for describing the world at the scale of mazes. And here, to see the force of the example, it's important to, for me to emphasize a rider that's under number 9, that that this is the stipulation: mazes cannot be described simply in the language of the fundamental physics. If all they consisted of was this diagram, of course they could. That's why I wanted to stipulate that they consist of more. So no, there's a lot that goes into a maze. If you wanted to describe a maze in the language that's particularly apt for describing things down at the level of T-junctions, it would be as hard as it would be to describe a human being, what it is to be a human being in the language of quarks. Right? It'd be incredibly hard. OK. So it's open to a Humean in a way that it's not, I think, a live possibility, at least not clearly a live possibility for the normal view, to say there are just two different sorts of objective chances that pertain to this world. One is broader in scope. It's the objective chances that come out of the quote-unquote fundamental physical laws. But then there are also probabilistic laws that apply to mazes, and these are independent of each other. So you explicitly disavow imperialism. Now this leads to an awkward question, which is, which of those chances should guide credence? Like, if you were sort of looking at a particle that was entering a maze, and you knew the T-junction chances, and you knew the maze chances, which ones should you use to make your prediction? The one thing I want to end with is, I'm not sure if I'm going to be able to get through this quickly, and I do want to stop on time. That second question about credence and chance, that's going to rise anyways. Like, even if you say, all right, that question makes me a little bit too awkward, I'm going to retrench and just demand that a Humean approach to chance just build in imperialism. The way it builds in imperialism is there's only one chance distribution you're allowed to posit. No, it's the one that comes as part of the package system, the best system written in the language of fundamental physics. There are no other languages that you can appeal to. So you could say that. The problem is not going to go away. And this was actually pointed out by philosopher Itai Nissan Rosen. So credit where it's due. And I think he's right about this. It's a really interesting point. If you're a predictor in a world like this, and you have, you've done a lot of studies of mazes, and you know that when particles enter mazes, what did I say? 20% of the time they exit from the white dot. And here's a particle entering a maze. So far, if you know nothing else, you should say, all right, based on the reasonable thing to do is just a bit of basic statistical inference. The only salient information I have about this case is it's representative of all those other cases. And so a reasonable credence for me to have is that there's is 0.2 for it exiting from the white dot. Now, if you have the normal view of chance, and someone comes along and says, hang on a second, suppose I actually tell you what mazes are like inside. So that you can see where the probabilistic behavior has to come from. And suppose I just stipulate, or we just adopt as a working hypothesis that the Markovian condition is met and particles carry no trace, no memory trace. If I suppose all that, then I'll have to shift my probability to 50%. And I will have to say, well, holy shit. I just had, the past data that I was using was just absolutely flukish. That's what I would have to say if I had the normal view. The question is, if you have a Humean view, why say that? Right? Why not say, sure, yeah, you've told me what these fundamental chances are. Why is that relevant now to my decision about how to place my bets with this maze? And I think, as far as I can see, it's not clear what the answer should be. Right? If there is no answer, this is going to be another very, very striking divergence, or sort of revisionary feature of a Humean approach to chance. Whereas on the normal approach, this information about chances renders irrelevant statistical information I had that I can now see to be highly misleading. On the Humean view, it's not at all obvious why that should be so. Okay, so closing questions. So one obvious question, and these are the questions I would sort of like to have answers to. Have I just like misunderstood Humeanism? Maybe, Is it like, no, Ned, you haven't gotten with the program right. If you see the view correctly, you can see that there are well-motivated ways of developing Humeanism where it doesn't have any of these revisionary consequences. The only thing I would want to emphasize is that you don't want to avoid the revisionary consequences the way Lewis did. You could try that. You could just say, it's going to be a constraint on the way I develop my Humeanism that's just not allowed to have these revisionary consequences. But the whole point of the discussion about rationale was like, you want to be able to say that with a clear conscience. You want to, at the end of the day, be able to say, it's not just that I've like met that constraint, but I can see why, given my background in Humean metaphysics, it's really good for us to have this concept that works this way, right? So that's what I have in mind when I say, when I pose the question the way I did, are there well-motivated Humean views that avoid the consequences? And then, the other question, and this would be for the Humeans in the room, has the kind of rhetoric I've been using along the way been inappropriate? Because my rhetoric has been a little bit critical. Should we, in fact, view this kind of revisionism about chance as a feature and not a bug? Okay, that's it.